How you going, guys? Curtis from Cutting Edge Engineering. Today's job, we have a Planetary carrier out of a final drive from the 740 articulated dump truck. So this houses the Planetary gears of the final drive in the differential. This is used to convert the power from the engine through the transmission into the 3 differentials. There are actually 6 of these on the 740 dump truck. That is 2 for each diff. As you can see in the housing, there are 3 pockets. Each of those pockets hold a Planetary gear. Then there is a pin that goes down through the housing to hold the gears in place. The center hole has the main axle going through it, and that goes from the diff center out to the final drive. There's also a cover plate that gets bolted onto this to hold everything inside, and then this gets bolted back into the final drive assembly. These triangular holes, they don't actually do anything. They are just part of the structural casting, and that adds a little bit of strength and also reduces a little bit of weight. And the reason this has come in for repair is 3 of the thrust faces for the Planetary gears have been damaged. So I don't know the exact cause of this failure. It's more than likely just going to be general wear and tear. Something that could have contributed to something like this happening could have been lack of oil or things not put back together correctly if this has ever been rebuilt. So what we're going to be doing is machining the thrust faces. Once they've been machined, our customer can then add an extra shim into the shim stack and they can put this back to work. Because just to replace this Planetary carrier is $7,800. So another repair method would be metal arc spray or flame spray the worn area. But that has been known to lead to cracking and distortion because when things heat up and cool down, they do pull out of shape, and that could lead to a failed repair. So the customer and I have decided we're just going to machine that down so they can put a new shim in there, which means less downtime and they can get this back to work. But the problem with machining those thrust faces is their location. So not only are they down inside a housing, but we only have a very small hole to work through. So I am going to need to make up a special boring bar to go in our facing head. So to make our boring bar, I'm going to be using a scrap piece of 38mm 4140 chrome bar. Now I've got that set up, I'm going to machine the OD down to within 1/2 mil of its finished size. Now with that done, I'm going to machine this end down to fit inside the boring and facing head. So now with that rough down, I'm going to change out to my finishing insert, which is a TNGG. I'm also going to increase the RPM and lower the feed rate, which will give us a nice surface finish. The end that's going in the boring bar, we're aiming for a diameter of 18 mil. So I've got that spot on. Now I'm going to machine 0.5 mil off the rest of the bar, and that will bring it down to 30 mil. And I'm machining it to that diameter so it goes down inside these holes. That hole is 47 mil in diameter, and we need to machine about 15 mil off the thrust faces. So that will give us a little bit of clearance and maximum rigidity on the boring bar. Now with that done, I'm just going to chamfer the edges and part it to length. So that was pretty quick and easy. Let's see if it fits. So that fits really well. Now we just need to do some milling and drilling.
Come on. Hey.
So the first thing I'm going to do is drill the hole for where the tool is going to be fitted. I'm just going to eyeball the angle and the location of where that tool is going to be. It's not super critical, just as long as I've got clearance under the bar when I'm cutting. So I'm pretty happy with that angle. Now I'm just going to find center. So I'm just going to use a 10mm carbide end mill to create a flat surface, so I've got somewhere for my drill to start. So that's drilled, now we're just going to check to make sure our tool fits. So now I'm going to change the setup. I need to mill the flat on the top of the boring bar for the grub screw that's in the boring head to seat against. While it's in that position, I can then drill and tap the hole for the grub screw that's going to lock the tool in place. Righto guys, so that's the boring bar made. I'm just going to install the tool and test fit it in the housing to make sure we've got enough clearance. So that's going to work out really well. Now we need to get the housing set up in the mill. So now I'm going to set up the boring and facing head. This is a Jin brand. It is exactly the same as many other boring and facing heads on the market, except this one was just a little bit cheaper. Now with my boring bar installed, I'm just going to feed it back so I can get my starting position at the edge of the hole. So we're set up ready to start facing. We're just going to take it real easy on the first pass just to make sure the setup's going to work out and the boring bar's not going to have any vibration. Right, so our first pass hasn't cleaned up. I'm going to take another 0.2 of a mil and hopefully we can get that all nice and clean. Righto, so that area is cleaned up enough that I can get a measurement. Unfortunately, we haven't been able to reach the outside of the hole, but that's not going to be a problem because the shim doesn't go right to the edge of that face, but I will end up extending out the tool to cut that down level once all the precision machining is completed. So now we're going to take our measurement. And to measure it, I'm going to use my internal micrometer. So that's measuring at 90.96. We still have a little bit to come out in order to make room for our extra shim. So the measurement we're aiming for is 91.25. That is the height of the gear, plus the 4 shims, plus an extra steel shim, plus 0.3 of a mil for an oil gap. So to get this to size, we've still got another 0.25 of a mil to take out. So we've got that measuring to size. I'm just going to extend the tool so I can remove that outer ridge. So now with that face done, I'm just going to rotate the part. That'll give me better access and visibility. And then we can set everything up and do it all again.
Hi, me. Hi, me. What is it? Is it his pig? Are you looking for Piggy? Look at him go. Go find it. Go get it. Go.
Where'd you go? Where'd you go? So the way this boring and facing head works, in order to get it to feed out, there is a collar, and that collar engages a pinion on the inside. They do give you a little handle that goes into the collar, which stops it from rotating and allows the feeding to start. So there are 3 feed speeds. It starts off at 0.04 of a mil per rotation and goes up to 0.12 of a mil per rotation. There's also a little dial on the front of the boring head, which you can use for feeding the tool in or out. Righto guys, so that's this repair completed. This one didn't take too long. For those wondering, will I be charging my customer for that boring bar I had to make? Yes, I will be charging him, but not the full amount. It will be prorated over the next couple of jobs we do like this. So that's this one done. We're going to get it strapped down on a pallet and get it back to our customer. Thanks for watching. What was that? Right,
And I'm.
And I'm machining it to that diameter. Wait, did I say what diameter is yet?
Yes, that's
Okay,
why you're
right.
saying and.
Right.
Oh.
So it's very So now I'm going to change the setup. I'm going to turn the... So that fits pretty well spot on. Oh, duh. So I'm just going to eyeball the... Oh my God. So I'm just going to ball the angle... Oh. So there are 3 speeds in order to... Oh, wait, what'd you say? I'm just going to extend the tool out and just cut that outer ridge out.
What?
What? What do I need here right now?
Words.
Back towards me.
Well, where does the thing go?
What thing? In
The
there.
stick.
In there. So... So now with that rough down, I'm going to change out to my finishing insert, which is a TN... Is it? Fuck me. Oh, God. My hands are too big. Hang on. Can't get under it. Fucking God. That is fucking spot on.
How do you... So you
Look down the
eyeballed
drill.
it from that angle?
Yes.
Okay, I see how you did it.
Pretty good.
Hey. He's gonna be noisy. Ah! How is that one squeaking? I thought he killed it. He's alive.